This assessment asks us which of the molecules on screen, a ketone or an ester, would we expect to react most quickly with a strong nucleophile. Given that we're using a strong nucleophile, we need to first recognize that it's the carbon of the carbonyl that is electrophilic. And we can explain why it's electrophilic by drawing these Witten ion resonance form of both carbonyls. And so we can move the CO pi electrons onto oxygen to give us this resonance form. We can do the same thing on both sides. And now the question essentially becomes, how does this methyl group versus this ethoxy group impact this positive charge, right? The degree to which either carbonyl is going to be an electrophile is going to be based on how much positive charge is on that central carbon. Well, if we look at what the alkyl group, the methyl group, can donate by hyperconjugation. So hyperconjugation from this methyl group is going to make this positive charge a little bit more stable and therefore slightly less reactive. That might make you think this one's going to be the least reactive. But what can the ethoxy group do? Well, there are actually two things that it can do. The first is we can draw an additional resonance structure. That additional resonance structure is going to stabilize that positive charge, diminishing the amount of positive charge on that central carbon. So resonance is going to be important here. Well, as an electronegative atom, we can also pull electron density away from that oxygen by induction. And so that leaves us with a challenge, which is more important? Well, in this case, resonance ends up mattering more. So an oxygen that can donate by resonance is going to stabilize this positive charge more than the alkyl group that donates by hyperconjugation. As a result, ketones are going to be more reactive than esters. And that's going to be a general rule. Ketones are more reactive than esters.